Use symmetry in construction geometry. In this video, we'll convert sketch entities to construction, create a sketch mirror, and add a symmetry constraint. In Fusion 360, we want to carry on with our gear reduction housing. We're going to get started by creating a new sketch, once again on the front plane. From here, we need to make sure that we can reference some of the values that we've already created. We still have our layout sketch shown, but we're going to use the option to create or project them as construction geometry in our current sketch. So we're going to select Project or P on the keyboard, and we're going to select each of these items. Once we have them all selected, we'll say OK, and then we're going to hide our layout sketch. You'll notice that they're displayed in a different color. They are still able to be used for things like extrudes as solid geometry, but what we've done is we've created them as a projection into our current sketch. If we want to turn them into a reference-only type of geometry, we can select them all and use the line type construction. When we left-click, you can see now that they're dashed, and they're projected but only as construction references. This means we can no longer select their close profiles for things like extrudes. This is a great way for us to bring specific sketch entities from other sketches or even solid geometry into our current sketch. This way we can begin to create the layout of our housing assembly. We're going to get started by using our center diameter circle, starting from the origin. We're going to begin dragging this out slightly larger than our projected reference. We're going to draw a secondary one larger than that. We're going to begin again by going to the origin and drawing a circle that comes to about 70 millimeters. And we're going to draw one at the outside of our last or a third idler gear. We're going to drag this one out, and it's going to roughly go through the center of the second idler gear, but we want to make sure that we don't actually snap to any geometry. So this is going to be about 37 millimeters. From here, let's go ahead and use our line tool to go between these two sketch entities. Once again, we'll zoom in to make sure that we're not creating any additional references. And then if you accidentally select, you can right click and hit cancel and restart your line tool. But we want to make sure that we're creating tangent references between these two outside circles. We can add that as a constraint by selecting the line entities and the circles. And we'll go ahead and do this for the bottom one as well. This is going to be a portion of our housing that encloses the idler gears as well as our driven gear on the front side of our housing. So in order to make it as aesthetic as possible, we're going to use these tapered lines and make sure that we can include enough geometry to encompass all of the various idler gears. Now that we've got some of this laid out, let's go ahead and add some dimensions. To get started, I want to add a dimension to this inside circle here. I'm going to left click to place the dimension, and then I need to define what this is. In order to do this, I'm going to start by having an open bracket, and I'm going to start to type in my gear list so I can start to see what I have inside of my parameters. So remember that we're dealing with the drive gear in this case, which is the largest gear. So I'm going to select my drive gear diameter, which is 96 millimeters, and I need to add to that. So in this case, we have a parameter called gear clearance diameter. That gear clearance diameter is 4 millimeters, and that 4 millimeters allows us to have just enough clearance for the outside edge of the teeth of our gear. Now, just enough is not going to be good for us. We want to make sure that we have a little space, especially if this housing has grease or there's any additional components that go in here. We want to make sure that we have enough clearance. So instead of just simply adding that 4 millimeters, we're going to say plus and add more brackets. And this is going to be our gear clearance diameter value, which is 4. And I'm going to multiply that by 2. And then I need 2 brackets to close this off. Going to hit enter, and this should give us a value of 104 millimeters. So once again, we're using that gear diameter, which we know is 96 millimeters, and we're adding 2 of our gear clearance diameters to it. The next thing that we want to do is we want to define the size of this geometry here. Now, when we do that, there's a couple different ways we can do it. Once again, we can define it as a diameter, or we can define it as a relationship to something else. So in this case, I'm going to create it as an offset. And this is going to be my gear clearance diameter value, which is 4, but I'm going to multiply that once again times 2. What this does is it gives us an offset value of 8 millimeters between the radius of the circles. So this gives us an overall difference of 16 millimeters, which is different than the 8 millimeters that we had for this value. So now that we have those two defined, let's go around and let's add a few more. This value here is something that we don't really have a parameter for. We're just going to have to use some of the other parameters to help define it. So we're going to start on the right-hand side, go between these two. And once again, I want to use the gear clearance diameter. I'm going to multiply that by 2, giving me 8 millimeters. Since I know that's not going to work on this side, I'm going to use that same value, that gear clearance diameter, but I'm going to multiply it times 4. Once again, I don't really have a value for this because we're just creating a sketch that has enough geometry to encompass our idler gears. So basing it still off of that original value means that any ratios that we adjust, if we modify the diameter of our large gear, our drive gear, that means all these other values are going to update accordingly. So that's why I want to make sure that I use a relationship to that gear clearance diameter. Now that we have these set, let's go ahead and use our center diameter circle tool, and let's add some center diameter circles. I know that I want my input and output shafts to be 10 millimeters, so I'm going to manually enter that value. But then I want to place some more center diameter circles, and these are going to be using our idle gear shaft values. That's going to be an 8 millimeter value. And again, we're going to just go ahead and place and click to place that. And again, if you forget, you can always go back to your sketch dimensions, apply that dimension, and then simply select the correct user parameter and hit enter on the keyboard. Now that we have our center diameter, the clearance for our shaft, and then we have the shaft clearances for the various idle gears, what we need to do is we need to create the mounting point locations. In order to do this, we're going to use a center diameter circle, and I'm simply going to place one in the bottom right. And I'm going to place 2 at the exact same location. I'm going to do this over here as well. I'm going to place 2 at the same location, making sure that they are concentric, and then I'm going to hit escape on the keyboard. In order to find the location of those, I'm going to use a line from the origin to the center point, and I'm going to do the same thing over here. I'll hit escape, and then I'll convert those lines to construction. These are only going to be references for adding dimensions. So I want to make sure that I create these references. In this case, I'll add a vertical line. We'll OK, we'll hit escape, and then we'll convert this to construction as well. So now we have a vertical reference, and we have this angular reference here. Since we left this under constrained, we can move it around if we want. But in the end, it's not really going to matter where that line is because what we're going to be doing is creating a dimension from it. So using our dimension tool, going from our vertical line to this line here, we're going to drag it down and add a 45-degree value. We're going to do the same thing, even though these two are offset, adding that same 45-degree value. Another thing that we can do if we want to keep this as a relationship, instead of manually entering it, we can select the original 45 and hit enter, and this will create a link between the two values. This means if I change this to 50 degrees, both of them are going to change. Once again, using this type of modeling approach is helpful, especially if you want to maintain this parametric link. Now we need to define what the diameters are going to be. In this case, I'm going to select the inside, and these are going to be our mounting bolts. So we'll hit M on the keyboard, and this is mount bolt, and I can hit enter for that. And I'll do the same thing over here, mount bolts, and we'll hit enter for that. Now we need to figure out the offset that we need, because this is going to be the center of the bolt going through, and we need to figure out how big the rest of this is going to be. Well, we don't really know at this point. We haven't picked out hardware. So I'm going to manually enter a value of 2 millimeters. And I'm going to do the same thing over here, but I'm going to select that original 2 millimeters. So once again, I only have to change it in one place. So I'm going to hit escape to get off my dimension tool and take a look at what I have so far. Now that I've added a few different things, I'm going to show a few more tools that can be extremely helpful when we're creating these parametric sketches. I'm going to add a couple more sketch circles over here, and I'm going to hit escape. Then I'm going to take a look at my symmetry constraint. When we have a symmetry constraint, we need to select our entities. First, we're going to go our first entity, our second entity, and then we need to select a mirror line. And we don't have one in this case. But if I select this vertical line, notice that it moves it all the way over here. We do the same thing to the inside ones, and then we select that vertical line. What we've done is we've added symmetry across that line. Let's hit escape on the keyboard. Let's create one more line, and this time it's going to be horizontal. We're going to select it, convert it to construction, and then we're going to use the mirror tool. This will allow me to select all of the different elements that I want to mirror. And then I select my mirror line and say OK. And now I've created all of those fully constrained and fully defined sketch elements that are parametrically linked, meaning if I change this value to 4 millimeters, all of them are going to increase. If I change it to 2, they're all going to decrease. Let's make sure that we finish this sketch and take a look at what we've done. We've added a lot of references, we've added a lot of parametric relationships, which means that we can always go back to modify, change parameters, and we can make adjustments to any of our values. Let's go ahead and minimize this so we can see. If we take a look at our drive gear teeth, and I change this to 60, everything updates, but you'll notice that there are some issues because of the tangency between our idle gears. If I change it back to 48, notice that it doesn't go back to the original location, but it does satisfy everything that we've done. So making those adjustments can update our sketches, but we do have to model in a specific way to make sure that all the updates take place. Because the drive and driven gears have that 1-to-3 relationship, they'll update just fine. But our idle gear was manually entered, and that value does not change based on any of the other parameters. So if we wanted to make a true updatable, fully constrained parametric type assembly, we would need to figure out some sort of relationship to get that 10-tooth gear in there based on the distance between 2 points or diameters. I'm going to use Control Z to undo and put this thing back on the right hand side how we designed it, and I'm going to save this before moving on.